Mercury vanishes from our skies for months at a time, then suddenly reappears as a brilliant evening star that ancient civilizations called the messenger of the gods. This tiny world completes an entire orbit around the sun in just 88 days, faster than any other planet in our solar system. But here's what blows my mind. Mercury can appear up to 28 degrees away from the sun during maximum eastern separation, yet most people will never see it once in their entire lifetime. Did you know that Mercury is actually easier to spot than most stars when you know exactly when and where to look? What is eastern separation? You're looking up at the night sky, and there's Mercury. But wait, how is that even possible when everyone says it's impossible to see? That's where eastern separation comes into play, and it's absolutely fascinating. When we talk about eastern separation, we're describing the angular distance between Mercury and the sun as seen from Earth. Think of it like this: the sun is your reference point, and Mercury appears to separate or move away from it in the eastern direction of the sky. This separation is measured in degrees, just like how you'd measure angles in geometry class. The maximum eastern separation is when Mercury reaches its greatest angular distance from the sun while positioned to the east of it. During this time, Mercury becomes visible in the evening sky right after sunset, appearing as a bright star-like object low on the western horizon. This phenomenon happens because Mercury's orbit is inside Earth's orbit. So from our perspective, it appears to swing back and forth on either side of the sun, like a pendulum. Eastern separation specifically means Mercury is trailing behind the sun in its apparent motion across our sky. The beauty of maximum eastern separation is that it gives us the best opportunity to spot this elusive planet with our naked eyes. Without this separation, Mercury would be lost in the sun's glare, making observation completely impossible for amateur stargazers. Why Mercury is special. You've probably tried spotting Mercury before and failed miserably, right? Don't worry, you're not alone. Mercury is hands down the most challenging planet to observe, and there's a perfectly good reason why astronomers have been frustrated with this little world for centuries. Mercury sits closest to the sun in our solar system, which creates a unique problem that no other planet faces. While Mars, Jupiter, and Saturn can appear anywhere in our night sky throughout the year, Mercury is essentially chained to the sun's vicinity. This proximity means Mercury never strays far from the solar glare that dominates our daytime sky. What makes Mercury truly special is its incredibly fast orbit. It completes one trip around the sun in just 88 Earth days, which is why the Romans named it after their speedy messenger god. This rapid orbital motion creates a cosmic dance where Mercury alternately appears on the eastern and western sides of the sun in quick succession. Unlike the outer planets that can be visible all night long, Mercury only gets brief windows of visibility during twilight hours. The planet's small size compounds the challenge. It's barely larger than our moon, making it appear as just a tiny dot even when conditions are perfect. This combination of proximity to the sun, rapid orbital motion, and small size creates the perfect storm of observational difficulty that has made Mercury the holy grail for amateur astronomers worldwide. Maximum eastern separation defined. You know how Mercury usually hides in the sun's glare? Well, maximum eastern separation is the exact moment when Mercury says, "Not today," and reaches its greatest possible distance from the sun as seen from Earth. This isn't just some random astronomical event. It's a precisely calculated phenomenon that occurs when Mercury reaches approximately 18 to 28 degrees of angular separation from the sun, depending on where Mercury is in its elliptical orbit. During this peak separation, Mercury appears furthest to the east of the sun in our evening sky, which translates to the best possible viewing conditions you'll get for this elusive planet. The term maximum is crucial here because Mercury's separation from the sun constantly changes as it orbits, swinging like a cosmic pendulum from maximum eastern separation to maximum western separation and back again. When astronomers say maximum eastern separation, they're pinpointing the exact day and time when this angular distance peaks before Mercury begins its journey back toward the sun. This moment typically lasts only a few days, making it a fleeting opportunity that serious stargazers mark on their calendars months in advance. The beauty of this definition lies in its precision. It's not just when Mercury is visible, but rather the optimal moment when Mercury achieves its greatest possible visibility in the evening sky. Understanding this technical definition helps you appreciate why timing is everything when hunting for Mercury in the twilight hours. When this occurs. You're probably wondering when you can actually catch Mercury in action. And here's the fascinating part. Mercury's maximum eastern separations follow a predictable rhythm that repeats roughly every 116 days. This means you get approximately 3 opportunities per year to witness this celestial event, though the exact timing shifts slightly each year due to orbital mechanics. The separations don't happen randomly throughout the year, they cluster around specific months, typically occurring in late winter, late spring, and early fall for most observers in the northern hemisphere. What's really cool is that Mercury alternates between eastern and western separations, so if you miss an eastern separation in March, you might catch a western separation in May, then another eastern separation in August. The exact dates vary from year to year, but astronomers can predict these events decades in advance with incredible precision. Each maximum eastern separation event lasts about a week, with the peak occurring on one specific day when Mercury reaches its furthest angular distance from the Sun. However, Mercury remains reasonably visible for several days before and after this peak, giving you a practical viewing window of roughly 10 to 14 days. The timing also depends on your geographic location. Observers at different latitudes will experience slightly different optimal viewing periods. Southern Hemisphere observers get completely different seasonal patterns, with their best eastern separations occurring during opposite months compared to northern observers, making Mercury truly a global phenomenon with local variations. Best viewing conditions. You want to see Mercury? Then you need to become obsessed with timing, location, and atmospheric conditions, because Mercury doesn't forgive amateur mistakes. The absolute best time to hunt for Mercury during maximum eastern separation is during evening twilight, specifically 30 to 45 minutes after sunset, when the sky has darkened enough to reveal faint objects, but isn't completely black yet. This narrow window is non-negotiable because if you wait too long, Mercury will set below the horizon along with the fading twilight. Your viewing location matters enormously. You need an unobstructed western horizon, which means no buildings, trees, or mountains blocking your view in the direction where the sun just set. Urban light pollution can kill your chances, so, if possible, drive to a darker location away from city lights, where the contrast between Mercury and the sky background becomes more pronounced. Weather conditions can make or break your observation session. You need clear skies with minimal atmospheric turbulence, which means avoiding nights with high humidity, haze, or strong winds that cause excessive twinkling. The best atmospheric conditions occur during stable weather patterns, often a day or two after a cold front passes through your area. Seasonal timing also plays a role. Some maximum eastern separations occur when Mercury appears higher above the horizon than others, depending on the angle of the ecliptic relative to your local horizon. Spring separations are typically best for northern hemisphere observers, while fall separations favor southern hemisphere viewers. How to spot Mercury. You need to master the art of systematic sky scanning because Mercury won't announce itself with flashing lights. Start by finding where the sun set on the western horizon. That's your reference point for everything that follows. Mercury will appear somewhere along the ecliptic, which is the imaginary line that the sun, moon, and planets follow across our sky. During maximum eastern separation, look for Mercury roughly 15 to 25 degrees to the left of where the sun disappeared, depending on the specific separation angle. Here's the key trick most people miss. Mercury looks like a bright, steady star that doesn't twinkle as much as real stars do. It typically appears as a yellowish or orange-colored point of light, brighter than most stars but not as brilliant as Venus. The best strategy is to scan systematically from the sunset point leftward along the horizon, looking for any star-like object that seems out of place or brighter than expected. Mercury stays relatively low to the horizon, usually appearing no higher than the width of your fist held at arm's length above the western horizon. Don't expect Mercury to be obvious. It often appears dimmer than you'd anticipate, especially if atmospheric conditions aren't perfect. Use nearby bright stars or planets as reference points to help guide your search. If you spot what you think is Mercury, watch it for several minutes. Planets appear steadier than stars, which tend to twinkle more noticeably. The planet will also set relatively quickly, disappearing below the horizon within an hour or two of sunset. Equipment needed. So you can absolutely spot Mercury during maximum eastern separation with nothing more than your naked eyes. No telescope, no binoculars, no fancy gadgets required. This might, actually surprise you because Mercury has a reputation for being impossible to see, but during optimal separations, it appears bright enough to be visible without any optical aid whatsoever. However, binoculars can be your secret weapon for making the hunt much easier, especially 7x50 or 10x50 models that gather more light and provide a wider field of view. Binoculars really help you scan the twilight sky more efficiently and can reveal Mercury even when atmospheric conditions aren't perfect. They also make Mercury appear noticeably brighter and easier to distinguish from background stars. Now, a telescope isn't necessary for simply spotting Mercury, but if you want to see it as more than just a point of light, even a small telescope will reveal Mercury's phases, kind of like how the moon changes shape throughout its cycle. For photography enthusiasts, a camera with manual settings and a sturdy tripod becomes essential equipment, along with a telephoto lens to capture Mercury's tiny disk against the twilight sky. One piece of equipment that's absolutely crucial, regardless of your approach, is a reliable star chart or astronomy app on your smartphone. These help you know exactly where to look and confirm you're actually seeing Mercury rather than a bright star. And honestly, the most important equipment is actually your patience and persistence, because Mercury observation requires multiple attempts and perfect timing to master successfully. Duration of visibility. You get roughly 10 to 14 days of reasonable viewing opportunities centered around Mercury's maximum eastern separation, but here's the catch. Mercury isn't equally visible throughout this entire period. The peak visibility occurs on the exact day of maximum separation, when Mercury reaches its greatest angular distance from the Sun and appears highest above the western horizon during evening twilight. On this optimal night, Mercury might remain visible for up to 90 minutes after sunset under perfect conditions, though typically, you'll have about 60 minutes of good viewing time before it sets below the horizon. As you move away from the peak date, Mercury's visibility window shrinks rapidly. Just 3 days before or after maximum separation, your viewing time might drop to only 30 to 45 minutes after sunset. The viewing window continues to compress as Mercury begins its orbital journey back toward the Sun, eventually becoming impossible to spot as it gets swallowed by solar glare. What makes this timeline tricky is that atmospheric conditions, your geographic location, and seasonal factors all influence how long Mercury remains visible each night. Northern observers during spring separations might enjoy slightly longer viewing windows, while observers at southern latitudes during winter separations face much shorter opportunities. The key insight is that Mercury's visibility follows a bell curve pattern. It gradually becomes easier to spot as maximum separation approaches, peaks for just a few days, then rapidly becomes more challenging until it disappears entirely. This compressed timeline means you can't procrastinate when Mercury becomes visible. Common viewing mistakes. You're probably sabotaging your own Mercury observations without even realizing it, and these mistakes cost countless stargazers their chance to spot this elusive planet. The biggest blunder is looking too early after sunset. Many people start scanning the sky immediately when the sun disappears, but Mercury won't be visible until at least 30 minutes later when twilight deepens enough to provide sufficient contrast. Another fatal error is searching too high in the sky. Mercury during eastern separation stays remarkably low, typically appearing no more than 8 to 21 degrees above the horizon, which is roughly the width of 2 fists held at arm's length. People also make the mistake of expecting Mercury to look like a bright, obvious planet when it actually appears as a modest, star-like point that's easily overlooked if you're not scanning systematically. Timing your observation session wrong kills more attempts than bad weather. Mercury's visibility window shrinks rapidly as you move away from the peak elongation date, yet many observers try weeks before or after maximum separation when Mercury has already become too faint or too close to the Sun. Geographic confusion ruins observations too. Northern Hemisphere observers often attempt to spot Mercury during autumn elongations when the ecliptic angle makes it nearly impossible, while the same elongation would be spectacular from the Southern Hemisphere. Don't confuse Mercury with bright stars or aircraft. Mercury appears steadier than twinkling stars and moves much slower than planes. Finally, the most expensive mistake is giving up after one failed attempt instead of trying multiple nights around the elongation peak. Photography tips. You can absolutely photograph Mercury during maximum eastern separation, but success depends on mastering timing, equipment setup, and post-processing techniques that most amateur photographers overlook completely. The golden rule for Mercury photography is shooting during the optimal twilight window. Start capturing images 30 to 45 minutes after sunset, when the sky has darkened enough to provide contrast, but Mercury hasn't set yet. Your camera setup becomes critical here. Mount your camera on a sturdy tripod with a ball head to eliminate vibrations, and use the longest focal length possible, ideally 200mm to 600mm or more, to make Mercury appear larger than a tiny dot. Manual camera settings work best. Shoot in RAW format, use a relatively small aperture like f8 for sharpness, keep ISO low at 100 to 200, and adjust shutter speed based on your light meter readings. The focusing technique separates successful shots from failures. Turn on live view, zoom in on Mercury digitally, and focus directly on the planet's edge until it appears tack sharp. Use manual white balance starting around 5500 Kelvin and adjust based on the color temperature you're seeing through your viewfinder. Take multiple bracketed exposures since Mercury's brightness can be tricky to nail perfectly on the first shot. Post-processing becomes essential because Mercury often appears too dim and small in the original images. Enhance visibility through careful brightness and contrast adjustments in software like Photoshop. The key insight most photographers miss is that Mercury photography requires patience and multiple attempts across several nights around maximum separation, since atmospheric conditions and timing must align perfectly for success. That's Mercury's maximum eastern separation decoded. You now know exactly when and how to spot the solar system's most elusive planet during its brief evening appearances. Mercury won't wait for you. These viewing windows happen only 3 times per year and last just days. If this cosmic knowledge sparked your curiosity about our incredible universe, smash that subscribe button and hit the bell icon so you never miss another space facts revelation. Drop a comment below and tell me, have you ever successfully spotted Mercury, or will this be your first attempt? Until next time, keep looking up and exploring the wonders above us.